Hello, TCS 301s and 401s. Matthew here. Sunday, November 7th, 2021. We will be beginning our radio project a week from tomorrow. And this afternoon here, I'm going to see if I can build one of the radios that we will be having you build. And hopefully, in just a little bit here, be getting a signal and listening to the radio I built. Got my workbench set up here, and hopefully I have the tools that I need ready to go. Have all the components, the circuit board that came in the kit, resistors, a tray full of capacitors, transistors, LEDs, and more. The display for the frequency plus the main control chip. And over here, later on, we'll put the case together. Got the little speaker. I also have things like I have a fan going for a little bit of ventilation. We are using lead-free solder. However, always good to have ventilation when you are soldering. I also have a magnifying light here that I'm going to use because my eyes just aren't what they used to be. Whoa. Here we go. Okay. This is the one thing I'll be using, the light with the magnifying glass, that you won't have. Otherwise, I'm trying to use all things that you would have and not cheat. So I'm using the same little soldering iron that you all will have, and I'm not using the fancy little arm setup that can hold circuit boards for you when you solder. Yeah, just in general, using the same tools that you'll have available to you. So, set my camera up over here. And we will see how this goes. I really have no idea. Not done this radio before. In fact, it's been a while since I did an electronics or soldering project at all. Get this down over my board. I have already put the main radio chip on here. Okay, so I did solder that before started recording. This is a main radio control chip that you can buy separately, and they bought this and put it as part of then a whole kit that we purchased. You could buy just the kit, just that radio chip, and then put all the parts together yourself. You can find things online that use this chip with Arduinos. More than you need to know. Let's get to some soldering. Although I did solder that already, I noticed that you probably can't see it, but it looks to me like there's a little gap when I inspected it. So there's four there. I carefully inspected it, and I think there's a little gap underneath one of them. So I'm going to give it, it's the second pin down from here. I'm going to give it, one little heat here. By the way, I already had. Okay. Then I'm going to bring in a little solder. I just got a little bit of a sharp point out of the way. Okay, you always heat up first and then bring the solder in. Okay. And then I'll take a look at that. One thing about these less expensive soldering units is you got to be careful because you're not putting them in a real secure stand, so you got to be careful. They're really hot and you don't want it falling off. Oh darn, I don't know why that one's causing so much trouble. Let's give this another try. 7 of them were easy and 1 is being problematic. I might be able to just heat what was there. Let's see if that worked. Just kind of move. I think I've got a connection now. All right, I'm going to put this soldering iron a little out of the way because it's time to get these resistors in there. So we have, I think we need 11 of these, but there's actually 12 of these 10 kilo ohm resistors. I did test them on my multimeter and they're pretty darn close to 10 kilo ohm. These are a couple of 220K. I think we only need one. They gave us two. And this is a 4.7 ohm. And again, labeled on this board, you can see 220K. Hopefully that's coming into focus. 10K, 10K. And throughout the board, you can see more 10Ks, 10Ks. The 4.7 ohm goes right over here. And throughout this board, it's labeled, telling us where to put capacitors, transistors, etc. I'm going to put the 4.7 ohm, goes in from the top. Okay. Pull it through so that it seats kind of nicely there. We're going to solder from this side, so then I'm going to bend them kind of out of the way. They're going to get soldered, and then they're going to get cut. I can probably cut them as I go. Keep stuff out of my way. I won't cut them as short as I eventually want them. So I'll trim them again later, but enough to be kind of out of the way. And I just have to continue this process. That was the 4.7 ohm. I'm going to grab one of these 220s. Again, labeled 220 there. Through the two holes for that. Pull it down. I do have a little pair of pliers here that could be useful for that. Okay. Then, once again, bend them so it's not going to fall back through. And on to the 11 10Ks that I have to get in here. So you want to take your time in certain places to really be sure, especially like you don't want to end up with something soldered somewhere where it's not supposed to be. The times when you can just be efficient, like I know I need each of these in here. I know they're the 10Ks, so I'm going to be as efficient as I can right now, rushing a little bit to save time for the things I need to slow down for later. Oh, by the way, quick little thing, because I have to take it off right now. I don't know if you can see, but there's Scotch tape here. Okay? Soldering this guy, it didn't have pins that would go down through. So it was a little bit tricky to hold it into place. There's a few different ways and tricks to do that. I chose to use a really thin strip of Scotch tape. And I need to get that out of my way now. And that was, again, just to hold that in place while I soldered it. It's a little bit of a risk. This is super static sensitive, that chip, and ripping tape off of it is a way to generate static electricity. So yeah, being a little cavalier, I think it'll work out though. Alright, 10K resistors. Okay, And if you're kind of like a crazy person like me, it doesn't matter at all which direction these colors go. But for some reason, my mind wants them to all go the same direction in this little line here. Yeah, not something that matters. Just something my mind cares about. Pull these through. Decently seated there. Straighten it a little. Bend these back out of the way. On to the next. Okay. This would be the point in the video where you might, fast forward. You'd be like, yeah, Matthew, but this is boring. So fast forward till you're done putting the resistors in. I understand. All right, 4 10Ks down, 7 to go. Let's see here, another 10K over here. Wow, those are sharp. Oh, okay, so even though I bent this one, the end's cut off, it decided to fall out. You know what? Silly Matthew, bend them opposite directions, especially when they're short. Okay. This is a situation where I definitely miss my little stand where I can clamp the board into it and hold it up off my work table. But again, you can get it done without it, and we don't have enough of those setups for everyone. Oh darn. Amateur video time. The natural gas water heater located in our garage just turned on. Jackie is doing laundry. Not sure how much that'll affect the sound, but really I'm just babbling right now, so not a big deal. Alright, one more 10K. Brown 10K yet another 10K resistor with the brown side to the left. Makes zero electrical difference, but boy, it's just so satisfying to me to do it all neat and tidy like that. You all know what I'm talking about. these colors here, brown, and what does it do? Looks like green, black, red, and brown again. Okay? Those colors, there's a code, and you can read that code. Each of those colors stands for a certain number / power of 10. And you can use those colors to figure out what the rating of the resistor is. So apparently, brown, green, black, red, brown is code for 10,000 ohms or 10 kiloohms. So that's what I'm talking about. It does not matter if I had flipped it this other direction, so the red were up on this end with the brown stripe, makes no difference electrically. Okay, but for some reason in my mind, I like it to be the same direction for each one of them. Emotionally satisfying for no good reason. Okay, 4, 5, 6, 7. Gotta find, okay, there's an 8th 10K right there. Let's see. Oh, there's another 10K right in the middle there. 10K number 9. And 2 more 10Ks. Oh my gosh. Terrible. This one. Okay, the lengths that a crazy person will go to, turning it around, makes no electrical difference. But just so satisfying to have them all oriented the same way. Then we could debate a long time which way these should go, since now they're going vertical instead of this way like all the others. We could debate, but of course the way I did it is the right way. Last resistor. So we're going to have one extra 10K and one extra 20K. This guy in here. Okay, 220, 4.7, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 of the 10Ks. Then I'm going to turn it over, and one at a time, I'm going to put my finger pressing up on the bottom so I know it's nice and flush. Okay? Then I'm going to bend this one this direction, cutting a little off of it, and I'm going to bend this one the opposite direction, cutting a little off of it, and I'm just going to go and do that for each one, leaving maybe a little less than a centimeter sticking through on each one, getting my finger firmly placed so I'm doing this one so that I know that it's in the right position. so I can get to them. Okay, bend them opposite directions so they stay a little better, and so on and so forth. Get my finger on both of those at the same time. Cut them at the same time. The underside of my magnetic thing makes for a nice garbage pickup of all those little pins. I'm a strong proponent of clean as you go. Definitely different workbench styles for different people, but yeah, my way's the best way. You know, that's kind of just how it goes, right? Yeah, I just think that if you can keep organized as you go, you're going to save yourself a lot of heartache as you have all these little pieces and such. I'm going to bend that off then. So there's so many all in one place here that kind of bending them all every which way. You can kind of see that. Making my way here. Okay, cut this one. Bend them 2 different directions. And on to this one. Uh-oh. One of my resistors just fell out. I'll figure out where that fell out of in just a second. This guy. These, cut them all at the same time. Alright, the one that fell out of right here because I believe I forgot to bend right here. I believe I forgot to bend the legs. Okay. Alright, let's take a look at this. Looks pretty ready to solder from that side. On this side, looks pretty good. So set it down. Basically, it's going to press against the table here. Okay. Gonna triple check here because soldering things in the wrong place is really a bummer. Turn it back over. 10, 10, 10, 10, 10, 10. How am I seeing that they're 10 so quickly? I'm just saying the same color pattern on each one different color pattern on this 4.7, different color pattern on this 220K, and then 10 and 10. I think we're good. Time to solder. I do soldering like my dad taught me how to light birthday candles. You start on the side of the cake opposite you, so your sleeve isn't over the lit candles when you try to light the other ones. Think about that. It makes some sense. I'm going to start over in this corner. Heat this guy up. Oh, you know what I didn't do? I didn't clean this and then re-tin this. Okay, there we go. I think that will work a little better now. Okay, heating up the wire and the solder hole. Start getting a feeling for how long it takes these particular pins to heat up. Okay, that one's a little ugly. Pretty it up a little bit. There we go. That one must be over here. Tips seem a little inconsistent. See if I get it more of an angle, if that will work. There we go. Much better. Okay. Get the solder down low. Good. So we'll have to check that one. It's soldered the one next to it at the same time. Hopefully, I can't have an electrical connection between those two. I'll have to check that in just a minute. Might have to do some solder scraping. Get it down at more of an angle, seems to be working better. Oop. I'm going to stop a sec before I forget. Two things I need to check. Gotta make sure this guy doesn't fall off. Burn me. Okay, so two things. One is, yeah, over here I was worried those two had been soldered together, but they were not, so that's good. Over here, I brought my soldering iron down too far, and these holes right there, I got this one soldered shut. So let's see if I can open that up, because a pin is going to have to go through that later, and can't have it closed. Oh, looks promising. Right. Not sure if you can see that, but that was soldered shut. Got soldered from when I soldered right next to it. Okay, as long as I've stopped soldering for a minute, going to cut off some of these longer pieces that are now just in the way of the ones that I already soldered. What's going on there? Standing up and out of the way. Maybe this will work better. Okay, right now I'm using a tool you probably won't have. It's just like super pointy guy. You can find something pointy if you need it. These two cuts. By the way, I could not find my really small snips. You will have smaller, easier to use ones on a circuit board than the ones I'm using right now. Okay, soldered. continue with the soldering. These take up more solder than you would think. Seems to suck through into the hole and out the other side. You want just a little blob of it on this side. That's what I want. If I could do that with every one, come on. Go. Yeah, practice definitely helps. This is definitely not something I do every day. Way. Mysterious to me. mysterious why that one would be so much harder than all the others. I'm sure it couldn't be me. Okay, those. I don't see any pins sticking through that are not soldered. It's a little bit of a bummer. That one ended up pushing through more than it would be ideal, but that'll be okay. We'll bend it up out of the way. The rest of them are nicely seated, nice and low. That one pushed out a little bit. So let's push all of these up. Up. As I push them up, if the solder weren't holding well, I would notice a little jiggle, and that would signal to me to resolder that one. I will be cutting those more cleanly with a nice small one of these that we have a bunch of at school, and that I just ordered a new one for myself. But for now, all those little cuts are pretty okay. Just quickly looking at each solder joint to see if I notice anything amiss. I think we're pretty good. I think I can cut this one a little bit further in. Okay, from here I have transistors to mount. So these little three-legged guys, see that? A three-legged transistor. And I'm going to double check my parts list here. Yeah, so there's those guys. On the board, I don't know if you can see, but there's a flat side and a curved side. And on the board, it shows a little flat and it shows a curved. In other words, I got to put these in the flat side toward the resistor. These, I have 3 legs to get through the holes. Not too hard though. Okay, so flat side toward the resistor. Okay, one thing I want to check is these resistors. How many do I have, and are they all the same? Okay. Resistors. Transistors. There we go. So 4, 5. 1, 2, 3, 4. Okay. Let's see. Put them all under here so I can see if there's any difference. In other words, there are part numbers that are labeled on them and the specifications. If they're all the same, then I'll just put them in the 5 different resistor slots and not worry about what's what. Okay, down closer. S9, 0, 12, 8, 331 on all of them. Okay, so 4, 5. Okay, 4 of them go here. Where do I see another one? I'm looking for 3 holes right next to each other. This could be another one where they gave us an extra. So I guess I'm just going to put the 4 in first. I'll save the 1 aside, and we'll see if a spot for that emerges later. There's number 2 in there. Because these are 3-legged, they seem to be holding well just on their own. So while I'm soldering these transistors, babble a little bit of science at you. So transistors are kind of the original modern electronic component. You think semiconductors? So Professor Bardeen won the Nobel Prize for transistor technology. I think it was his nephew, was my modern physics instructor at the University of Washington. Terrible teacher. Pretty brilliant physicist, but terrible, terrible teacher. Yeah, transistors were our first great success at harnessing our knowledge of quantum tunneling, which is at the heart of semiconductors. Turns out that electrons can pass through materials, kind of like as though if you walked up to a wall and you just walked right through it, which it turns out there's a non-zero probability that you could do that. You'd have to kind of like walk into walls for trillions and trillions of years, and maybe once you'd find yourself on the other side of the wall. Well, electrons walk up to walls, and they often find themselves just on the other side. And there's a predictable probability with regard to the rate at which they will do that. And we make use and manipulate that probability in semiconductors. And transistors were our first big success. As though all of human society can take credit for this. There were a few small portion of humanity that contributed to that, and we all benefit. or don't, depending on how you feel about modern technology and cell phones and TVs and everything that's run on chips. These transistors were the beginning of that, our understanding of quantum tunneling of electrons through materials. All right, regroup here. 4 legs to go. Good. Alright, transistor legs soldered. Phew. Okay. In. Can cut all of those guys off. They're not all being caught by my magnet. Clearly making the most riveting video ever here. I really hope that nobody watches this beginning to end. Yeah. Fast forwarding is a thing. Alright, transistors on. I think that we may be ready to put one of these guys on. Oh, I just touched the end of the soldering iron. Good job, Matthew. Okay. What's up and what's down? Oh, look at this. They gave me little dots. And I bet those line up with these little dots. 1, 2, 3, 4. 1, 2, 3, 4. Look at that. Hey, my transistors are a little bit in the way. So close to lining up. Okay, those line up. There we go. Alright, so all of those legs through. Now, I double check the picture and my little, got this here, you all should have that as well. And yes, indeed, those 4 dots are down toward the transistors. So I think that I can go ahead and solder those in. Okay, that out of the way. Clean you a little bit. Hey, it's hot all the way down here. I'm really quite terrible when working with heat, electricity, sharp things. I burn myself, cut myself, and shock myself far too often. Okay, decently tinned, I think. Clean that off. Okay, let's get this. Trying to get the solder joint, the pin, and the solder you're bringing in hot all at the same time. There we go. That's a nice little solder. Sometimes it's a good idea, contrary to the cake candle lighting technique, to do the pins with a big board like this, to do the two opposite pins and secure the corners essentially. Come on. Maybe. Okay, I can feel it getting really hot. For some reason the solder is not melting for me. Let's try again at a different angle. Well, that won't be the last time I burn myself today. You all should be less cavalier. Another thing I have going for me is I have very little sensation on the pads of my fingers. Some of you might be able to imagine why. So it doesn't hurt as much as folks who actually have like proper nerve endings on the ends of their fingers. Come on. Okay, I'm at a loss. I know I said do the corner, but I'm going to see if I'm still having trouble, like if I do this one over here. Okay, I feel like maybe the end of this is needing some definite cleaning. Oh, you know what? Although that happened, I was having trouble before, but when my soldering iron hit the floor, could have ended up with some junk on it that is not conducive to soldering. tin it again. Okay. Let's see. Hold this over here. Sure why, but that angle all of a sudden worked a whole lot better. Okay, so back on the back side here. Worked well for that one. Four corners. Now we'll see if we can get each one of these. Right down inside there. I'm finding that if I'm really careful about putting my tip in there, and I kind of bend the pin over a little so I'm really pressed against it, I'm having much better luck now. So apparently these pins don't heat as easily as like the legs of the transistors and the resistors. Okay, don't fall. Check out my, so I don't know how well you can see those there. One thing I check for is you don't want to see any pin with its little silver solder around it touching the one next to it. Okay. Electrical connections are important. When you need them to be made, they need to be made, and when they aren't supposed to be touching, it's very important that they are not touching. Okay, let's look at the other components we got to get in here. Got some great big capacitors. See here what's up with those. Guess we'll get the big capacitors in. Got a couple of smaller ones of that same type. So by the way, these are both capacitors. Okay, this is a much less expensive, simpler style, and I'm forgetting the name, but this is just a standard, sometimes ceramic, but just two plates separated by some semiconductor inside there. These are cylindrical and kind of a wrap in there. Quick FYI, if you're ever trying to do the do-it-yourself repair, so for instance, I had a friend who gave me a TV, said it doesn't work, you can have it if you can make it work. I opened up the back of it, I found one of these guys, great big one, and this end of it was bubbled out. That is the immediate sign that this type of capacitor is bad, if the end of this is bubbled out. Went to Radio Shack. Radio Shack still existed out there on Sprague, and I bought one of these guys. I put it in this LG flat screen TV, and the TV worked again for years. Alright, so, whoop, magnets. Careful. Okay, so let's take a look at what we got here. Are they all the same? I've got 100 microfarad 50 volt, 100 microfarad 50 volt, 100 microfarad 50 volt. Okay, all three of those are the same. I'm assuming these two green ones are the same. 10 microfarad 25 volt, 10 microfarad 25 volt. This guy is just labeled 22. So presumably somewhere on the board there'll be a place to put 22. I'm going to put that back for now. Okay, so 100 microfarad. Alright, so I don't know if you can see here, but got a couple of little 100 microfarad. So micro, it looks like a little fancy U with two legs. So that is where these guys go, is right there and there. And one over here. There's the three of them. So then I gotta remember if these guys are directional, because I think they actually are. I think it matters what direction these go. Let's take a look here. Okay, so that's interesting. C122. C11. I don't think their picture on here matches what I'm looking at. I'm just going to double check that for a second. The short, okay, so they are directional. The short pin is the minus side, and the longer pin, so there's a shorter and a longer, so this is minus, and minus goes in the side that is shaded. So short pin to the shaded. 100 microfarad, short pin to the shaded. I'm pressing it kind of like all the way down there. I think I'll do one at a time of these. So, although, yeah, that's interesting. Okay. Oh, I understand now. Okay. All right. So, Jackie, video's live here. I'm sure that all sorts of people will be just enamored watching this hour of Matthew soldering. Yeah, I have to say, if you're doing that, if you're watching this hour plus of Matthew soldering and not fast forwarding through large segments of it, I don't know, I'm a little worried for you. Okay. Getting that nice and hot. Come on. Get in there. Of course, I didn't clean or tin it again. See if it'll go for me. There we go. So the silly thing is, of course, once you get one successful, that should actually have kind of tinned the end for me. But I could have just done it to begin with. Might have been a better plan. Okay, pressing it on in there. Come on. There we go. Okay. I should probably... My sponge is getting a little dry. Okay, so there's one of them. Cut these legs off. Okay, next one, short leg through the negative, which is the shaded side. Okay, Matthew, take your time here, clean your end. Don't lose your parts. Okay, nicely tinned. Clean it really quickly again. Almost touched the really hot part again. Good. Press against this side. One thing is, when you get these big balls forming on the end of your solder supply, that doesn't always work the best. once again. Don't know what I'm doing inconsistently to sometimes have them work great. Let's get those out of the way. Of this type, shorter leg negative toward the shaded, bend this way. So easy for some reason. Okay. Alright, got 3 capacitors on here. Still got to put these 2 little guys on. They also have a short leg and a long leg. And see here, 10 microfarad. Let me make sure that that is, again, yep, 10 microfarads. Okay, so the shorter goes on the side with the little shading for negative. Now this one, it's going to get a pin over the top of it. So it has to be able to bend down out of the way. Okay, so it has to be able to go like that, because there's going to be something over the top of this. That is important. If I didn't leave myself enough leg there that it could actually bend, it would be very problematic just a little ways down the road here. So I got to hold that in place. Hold these back here. Okay. And then, if anything, if they slip back through a little, that's okay, because that just gives me more leg on the other side to work with and bend. Okay, looks pretty good there. Hey, Turns out having a really nicely tinned tip maybe makes a difference. Okay, so this is going to bend nicely out of the way there. Okay, now the question is, do we have a place for one more of these resistors, or did they just give me an extra one? I don't see any other places where... Oh, there it is. So I do see one other place right there. And I want to make sure that that is indeed where this should be going, because it is not labeled 10 microfarad. Oh, yes it is. Yes it is. Okay. Feel pretty confident then that I don't know where my other little... There it is. Short end through the shaded side. That one is not going to need to bend over, right? I mean, it's got these big tall guys next to it. So straight up and down for that one. Gonna work. Nicely cleaned. And then nicely tinned. Too much. Clean a little of that off of there. Okay. Wow. Yeah, maybe, Matthew, you just were doing a really bad job preparing your tip each time. What we can get to here. Got my sheet here. See if it gives me a little direction for what I should do next. Alright. I guess we're putting the LED in next. Okay, now, when we were doing the generators, I mentioned to you sometimes LEDs are directional. Those LEDs that we were using were not directional. That's why you could spin your generator either direction. This is a directional LED. And once again, the shorter leg is the negative. Starting to see a standard here. And on the board, looks like it's going at near the end of a resistor. Positive and negative are marked, and it's right near the corner. Let's see if that leads me. Well, okay, there's something that says up in the picture. I wonder if there's anything that says up here. Oh, that says up. There we go. Alright, so it's going at the end of this resistor, negative, so there's a positive, negative. Negative's going to go through short leg. Okay, and I'm thinking that the LED maybe shouldn't be pressed all the way against the board. Usually you want them up just a little bit. So I'm going to solder it so that it's sticking out just a little. It also allows you then, if you needed to bend it one direction or the other, just the littlest bit you could. So I'm going to hold that so that it's not quite against the circuit board. I'm going to solder it. That's going to be hard to do. Let's see here. What could I do? I could put something to block it, like this maybe. So this maybe wouldn't let it go all the way down, and then I could pull it out. See if I can make that work. Just improvising here. Okay, so see if this will work. Tinning. Getting the bulk of it off. Oop, come on. Okay. Thank goodness. That worked quite well. This will work as well. Yes. How does it look? Not bad. Bothers me that one end is a little further in than the other, but it sticks up just a little bit. That is going to bother me though, that it's off to the side. Not going to take the time to fix it though. Keep your crazy under control, Matthew. As long as this video is, and as long as this is taking me, I will admit to the fact that if I were doing this more just for me, my own style, not videoing it, I'd be taking a lot longer at this. I'd be moving a lot more slowly. I have time, and I would be being very painstaking. But I think that moving quickly here, which isn't that quickly, I'm still going to end up with, I hope, a working radio. And you all don't want to watch my 4.5 hour process. At least I hope you don't. Okay, got the LED in. Now they say power socket. Cool. So that's this guy, I believe, which is what the power supply will plug into. And where is it gonna go? It's got to stick off the side, and it needs 3 holes to go. Oh, look at that. Those 3 sideways things look like pretty likely suspects. Okay. So, interesting. Power socket. wires are going to have to go into that. Sometimes when you have little holes like that, it means that a wire is going to have to go through those at some point. I hope not, because that looks like kind of a hard soldering job. But, yeah, I guess we'll see how easy it is. This doesn't look easy, though, to solder the base of that. Wow, yeah, that doesn't look easy at all. Do they give me any hints? I don't really see. I'll put it under my magnifying, but not burn it on the... It's definitely where it goes. So I guess we'll go for it. There's a lot here, so I'm going to want it to get plenty hot. Then bring the solder in. Alright. Not near as hard as I thought it might be. Plenty hot. Bring the solder in. All right. There. Okay. I think we have a pretty good connection for all three of those. Alright. Okay, so the two little brown ones here, it looks like we can get to those next. They go near one another. Again, those two little guys are capacitors. They go on either end of this little guy, which I have to admit I'm not sure what this is. Could be a very small transformer, although I would expect 2 in and 2 out on a transformer, but let's see here. Does it say? Oh! Wait a sec here. 13560. So it is a crystal oscillator. So in fact, I wonder what exactly is in there. Usually oscillator implies there's some kind of a coil. I'm not sure what the crystal would be. And let's make sure. Okay, so the way that they have it in the picture, the 13560 needs to be oriented so you read it, right side upwise, the same as the Y1 and the 12M below and above it. So Y1 and 12M, where are those? Oh, there they are right there. Okay, so it's going to go in right there. And get get soldered. You notice how I'm taking the time finally to tin this each time instead of being hasty, because I thought I could save myself some time, but it saved me no time because I had so much trouble soldering many of those early joints. Okay, so get this down on there. And when you tin it properly, it seems to be working right away. Cool. Those are two of my best solder joints yet. Okay, now I believe these two little capacitors go on either end of this. There's a little symbol in there that is the classic capacitor symbol. Capacitors are essentially two metal plates, and you build up charge on one and it affects the charge on the other without there being actual flow between them. A ceramic capacitor like these two, the material between is ceramic, and it modifies the field from one to the other so that the effect of electrons on this side is just as we would like it on the other side. We measure capacitance in farads, or in this case these are microfarad capacitors. Alright, so I do not believe that they are directional. The picture does not agree. In other words, I don't think there's a positive negative. It doesn't matter which way these go in. So you've noticed resistors, it didn't matter, except for Matthew's obsession with the colored lines all go in the same direction, but actually electrically it doesn't matter. The LED mattered. The other types of capacitors mattered, but for these ceramic capacitors, I'm pretty sure, and the picture seems to be indicating that direction does not matter. The fact that one leg is not longer than the other is another clue. So with that, we're going to put these in here. But they do have a 22 on them. And this is not just me being crazy. It's nice to be able to read the components when they're in there. You know, you might have to go like, oh, what was that? So making it so that 22 is visible, pointing out that way, and making it so the 22 on the other one is visible out the other direction, I think that could be useful. Or, let's see here. Maybe we want the 22 facing the same direction for both of them. These are not super important considerations. But I am going to make it so that the 22 on both of them facing the same direction. A person would look and go, oh look, those two capacitors are the same, number 22s. Whatever exactly that means. Picofarad. Maybe that means 22 picofarads. I'm not positive. Okay, let's get those soldered. Take the time to clean this. Ugh. My sponge really needs to be re-wetted. I will be back in 22 seconds. Okay. tinned. Nicely soldered. Nicely soldered. Oh my gosh. I'm really amazed and quite pleased at, doing things right makes a difference. Clean, tin, and don't speak too soon, Matthew. A good solder. Okay. Clean on a nice wet sponge. These off. Jackie recently told me that I make odd sound effects and whistle and other such things all the time when I'm doing work like this. It's a little disturbing, the things you do that you're not really aware of. But as I'm making this video right now, I've been kind of noticing myself making little whistling and breathing noises and sound effects. And oh, sorry about that. Okay, look at this. We're getting there. Look at all those transistors, resistors, capacitors, our tuner chip for the radio, plug for plugging in the power supply, our readout for the station we're going to tune to. Okay, let's see what other parts we have here. We have a bunch of these guys. Wonder where they all go. 2, 3, 4. This looks like another type of capacitor. Oh goodness, there's another little number 22. So where might it go? There's another little 22. Okay, let's take a look here. Do I see a 22? 22. Boy, I don't. Oh, wait a minute. Nope. Well, in the pictures here, they don't show where another one would go. So for now, we'll think, oh, look at that. I stuck them all to the bottom of this. But for now, we'll put it in there. I'll leave them all on the bottom for now. Okay, so where's this guy gonna go? 104 it has listed on it. C4. So I see that there's a little capacitor symbol here. Oh yeah, 104, look at that. So I saw a little capacitor symbol. Again, the capacitor symbol is the symbol that shows two parallel sides with a line. Where are we at here? Just lost it. Oh, there we go. Two parallel lines with like a wire coming in either side. There's the 104 right there. That's the symbol for capacitor. Again, two plates separated, charge building up on one and affecting the charge on the other. Okay, so once again, I do not believe these are directional. The 104. And on the bottom of this guy, another one. 104, facing the same direction. Oop. Okay. And separate those a little. Those are going to get soldered. Now my question is there, because how many more did we have here? 2 more. Do I see more 104s? Oh, there it is. There's another one. Okay. We're starting to see that some of these parts they give us extras of, but we'll see. Okay, systematically looking here. I do not see another. Alright, just turn it over. And we will solder these. And get some of the excess off. Okay. It's wanting to tip on me. Okay. Very nice. Very nice. Here. There we go. Let's clean it. Okay. Getting there. Okay, so I think this might be an extra. What next? Okay, we have a shift potentiometer, they're calling it. Basically, a potentiometer is a fancy way of saying that we can vary the resistance. So as we turn the dial of this little guy, it changes the resistance, which changes the voltage that you're getting. And it is the standard classic way of just straightening the pins here of, for instance, changing your volume. So the more voltage, the higher volume. So you change the resistance and you turn it up from more voltage, less resistance, and vice versa. It's also how dimmer switches work. It's just a fancy potentiometer. You're raising the resistance, less voltage, dimmer light. Okay, so this is our volume, and it is going to go where? Right here? Looks like it. Okay. That's going to be another semi-tricky soldering job. Let's make sure I got that right. Right next to R11, okay. And what's going to hold this in place while I solder it? I don't think they're quite big enough, but we're going to give this alligator clip, no, not big enough. Another possibility, nope. Okay, how am I going to hold this in place? How I would normally be doing it would be using a little stand for soldering, but we can figure out a way to do it without. Let's see. Maybe I just have it kind of sit down on top of this. I just need it held in place while I solder it. Now I guess the other thing is if I can just get one, then it'll pretty much be held for the rest of them. Let's see if I can do it. Okay, let's see here. This one here. Pretty good. Except it moved a little. Okay. Did it move too much? And I caught it just as the solder was not quite hard. And pushed it into place, and then it hardened, and now it's holding it in place, but only one solder joint, so not super strong. So now I'm going to do the one, I did the one on the far left end, now we're going to do the one on the far right end. To hopefully be holding it decently in place. Okay. Good. Alright. Now on to, boy, they sure are close together. So if I use too much solder on these with them being so close together, it would make them touch, and that would be an electrical connection we wouldn't want. Alright, I've got the 5 pins. I'm wondering a little what I'm supposed to do with these two up here, if they're just support, or if they're supposed to get soldered, I don't know. They have little soldering pads. I have a feeling that I'm supposed to solder them just to make it stronger. I'm going to go with that. It's just that they're not right up against them. So I'm going to use quite a bit of solder here. quite a bit of solder. Again, I think that is just holding it as support. I don't think it's actually electrical. And because it's not close to anything else, I'm thinking I can use a ton of solder here. It's not always a good idea to like re-solder after you've soldered. And having said that, I'm going to give it a try. Okay. Worked out okay this time. I am still filming, Jackie, but you can still ask a question.
What time is those back testing tomorrow?
401s are testing on Tuesday. I don't know what the 101, 201 schedules are, but everything's in the morning. But I don't know exactly. The picture shows that I was indeed supposed to put a lot of solder on those two legs. Okay. Self-locking switches are to go in, so that's these guys. We're nearing the end of this. The board's starting to look. Okay, self-locking switch, button, antenna. Oh, it wants me to do it. Okay. Okay, so let's look at these buttons. Self-locking. Curious, I don't. Alright, they're gonna go here. They don't fit, they only fit one direction. I believe these are what you'll use for tuning up and tuning down. Interesting. Okay. So I want to get them pretty nicely pressed down in there, I think. Ow. Then I want to solder them. Trying to get it so that it doesn't necessarily sit on them as I solder them. Try. Need to be able to press harder. Okay, how are we gonna do this? That's the hot part again. There we go. Go. Yeah, as I worried. Not quite straight up and down now. So these are the sorts of things that, again, if this were a project of mine that I was, really caring about quality control, not just trying to get it done for the sake of a test assembly, I would spend the time to find a way to really clamp these switches in carefully and properly so it held them right squarely in place. But for these purposes, I think we'll be okay. They'll be a little cockeyed. Got to be careful though, because a lot of times hurrying up is a recipe for slowing yourself way down as you mess stuff up and have to redo it. Alright. Okay, the switches are all soldered in now. On to I'm surprised they want me to put the antenna on already. I'm not going to. I think it can wait. Okay, I've got that capacitor and that resistor on. That resistor. What do we got? It thinks that it's ready for I think it's missing some steps here. Okay, that said, we're just gonna do it. So I think we need to do these guys. Okay, so there's this guy. And I think this guy probably goes here. And it's going to hold this guy. Okay, now, see if we can get this in the right way. Okay, so, I don't know if you can see, but there is a little indent right there. Okay, so we've got a chip holder and the actual chip here. And these guys also have a little notch. It's going to be pretty hard to see, I think, but there's a little notch there, a little notch there, and a little notch right here. So we want all three of those to line up. Gonna double check if there's anything that indicates whether I have that right or not. Oh, here we go. little notch, they're showing the little notch there. Good. U-shaped cut, they call it. All right, so the U-shaped cut right there. We're gonna put this into my no, I'll put it back over here in the styrofoam for now. Okay. So another one with a lot of pins. Once I get a couple of them in, it'll be a lot easier. Now, I'm wondering, there's one pin with no solder on the board. I hope that means that I really actually don't need that pin, because there's 8 pins, but one of them has no solder connection. So we'll assume that that's by design and not a mistake. Okay. Wanting to put this, I want to hold it with my thumb, but that won't work very well. I wonder if I can hold it with my chest there. That seems to have worked. It's just hard to hold that first one in. I'm going to go to the opposite corner here, try the same thing. Also seems to have worked. Okay, so now with 2 corners held, I think I can do it the more conventional way here. This guy's a little bit in the way. And I'm not going to solder the pin that has no solder pad. That would just melt the plastic board. Okay, got all those in there. So the nice thing then is the chip here with the legs, it doesn't need to be soldered. You got to be a little careful with these guys. It's especially the top that is static electricity sensitive. But this will then just press down into this. Get them lined up. They all straight. There we go. Maybe. Good. Alright, got that guy in. We have a similar situation here, where this guy is going to hold the great big control unit. Okay, so this one also has what they call a U-shaped cutout here. Goes down on this end. Holy cow, I just realized how many pins I have to solder now. Whoa. Okay. Notice how that goes down on there nicely, and it's this guy bent over. These guys might need to bend over just a little bit as well. And we're going to solder all of those guys in there on this other side here. Goodness. Hopefully I can get a rhythm going for all of those, but at that point I'll be very close to done with the soldering. Not quite, but close. Okay. Because there's so many pins, they're kind of holding in place. Let's see how this goes. I'm going to set this out of the way. I'm going to set this on here. Yeah, that's holding in place pretty nicely. Let's see how this goes. Wow, that's a lot of pins. Alright, we'll start with this one over here. Nice. Then, as I mentioned earlier, we're going to do one. Oh, I'm going to double check that because it almost seems like it's not coming through as well. Yeah, it's kind of falling out. Okay. Okay. Okay, those are coming through nicely. Wonder why it's starting to fall out a little. Oh, did it do it again? No, they're still coming through. Alright, so again I'm doing like the diagonal corners just in hopes of holding it in there effectively, and then get to doing all of the others. Corners. This corner over here. Alright, I've got the 4 corners done. And now, see how effectively I can just move from pin to pin. It would be nice if this thing didn't move on me. Again, these are pretty close together. If I overfill it with solder, it's going to spill out onto the one next to it. And we can't have these pins connecting with each other in ways they weren't designed to. So I got to be careful to fill this with solder, but not overfill. This is working quite nicely. One thing to appreciate as we're doing this is the number of places that error could happen. It's kind of a lot of them. Like, I mean, one solder joint that doesn't make a good connection or makes a connection it's not supposed to make, and the whole thing doesn't work. You don't get to get close in things like electronics, computer programming. It's not very forgiving in some respects. Okay, the reason that's harder is because I can't press on it hard enough. other side. Solder here. All right, closer and closer we are getting. This now gets this big guy in it. Oop, totally missing. Okay, so this is troublesome, but all these legs are bent just out a little too far. That's troublesome because they have to be really lined up with each other. Okay, let's see here. If I get those two in the end, these two on this end. How are we up? I'm missing, just missing it. I'm gonna have to kind of painstakingly do this. Ooh. Okay, how are we doing? Just gotta take it slow because if one of those legs like totally bends sideways, like I see one about to do right there. Shoot. Okay, the completely bad connection. These guys over here don't quite want to go in. This is one of those situations where rushing it, I mean, it shouldn't be this hard, but it is what it is, and rushing it is going to cost a whole bunch more time. That feels better. Okay, I think I seated okay now. gonna over press it. I think I've got electrical connections for all those legs, kind of looking down there to see what they're doing. I hope that that's good. Okay. Now, what do we have left here? We have, it looks like a little switch of some sort. On off, maybe? Looks like maybe a little switch cover. I think I might be, oh, that doesn't fit very well, does it? Huh. I do think that this six-legged piece here very likely goes right here. As an on-off switch. And I don't think direction matters. Okay, all six of them through there. That's going to be for the speaker. No solder joint, no solder joint. Yeah, what are those for? It's a little bit disturbing. I have 4 solder joints right there. One's labeled plus minus. Gonna have to figure that one out. 3-legged. Interesting. Okay, but I feel pretty sure that the switch is supposed to be how would we get to that switch when it is in the case? Alright, let's see here. We're going to move to the speaker for a second. Got a speaker here, and it's going to solder in plus and minus there. Solder's on the bottom side, okay. So, they want me to solder it from this side. They want the red to be here. So I'll hold that. Will my alligator clip work to hold it this time? Will. Okay. Yeah, but that'll be in the way. Okay. It's going to work. Okay, I have these four holes. I'm unsure. They don't show anything in those. Maybe it's for a different application. Okay, so we're going to put the switch in here. Found the picture that verified this is indeed where it should go. Okay, connect these to the speaker. Red to the positive side, black to the negative side. And let's see if I want to strip these a little more or not. Oh, shoot. Take it easy on the speaker, Matthew. goes. Not awesome. Probably should have stripped a little more wire off of that. That said, grab my multimeter, continuity test, make sure that from this copper wire going into the speaker on over to here, okay, decent connection. Okay. Ooh. Hey, there's a hot soldering iron under there. Imagine that. Okay, now this black one on the negative side. That's a much better joint than the red. Nice. Okay. The red will work. A lot of times you twist speaker wires like this. Oh, well, look at that. This guy didn't stay. Back to that in a minute. But I don't know how much length I need for those, so I'm not going to twist them up. And I'm going to be gentle here, holding those where they need to be. Okay, let's think here. I think actually theoretically we are ready to go. It'll have to go in a case eventually in that, but if those two capacitors and that transistor really are extra, see if we can get this back in again in a way that will stay. There's a sharp pokey end of a electrical component under there. See, there's a bent one. Immediately when that happens, you're not getting anywhere. And, as you might have had experience with, if you bend metal like this back and forth too many times, it breaks off And well, that would be the end of this chip. Okay, let's be careful. Why does it seem like... I don't think I'm going to need to solder on it. I'm going to move that out of the way. I wish I could just leave it right there and it might stay, because I just really don't want to force it further and bend something. We'll see. You know, I'm actually gonna test this. I'm gonna turn the fan off. I'm gonna grab my power cord. I'm gonna lift this up out of my way. Okay. Short power cord. That's a pretty disturbing sound. Okay. $63, 4, 5, 6, 7. Okay, are we going down? Is this up? Okay. 107. Oh, hey, you know what? Okay. Besides super staticky, it's picking up a station. But some of you may have been wanting to scream into the video, Matthew, you forgot to hook up the antenna. So let's do that. Antenna. Okay, so the antenna is going to go here. They indicated like possibly some soldering, but I can't see why I would need to solder the antenna. I think the antenna needs a little screw. Okay. So all of these guys, which are mostly for the case, but maybe they could also work. Maybe a couple of them are supposed to be for the antenna. We will see. Doesn't really look like it. Well, it sure seems to me like we're missing something to attach this antenna. So, let's see here. Okay, well, for the purposes of testing, can I just get this to stay pretty well? So for the purposes of testing, if I do that, let's see what happens. On switch. Okay, KISS 98.1. I happen to know that I don't get very good reception in... Oh goodness, Christmas music. Okay, so big question I have is whether my terrible reception is something with troubleshooting the radio needs, or the fact that I'm inside my garage behind a big steel door with a not super big antenna. Test more on that later. Okay, this case. Let's see here. I'm assuming this brown paper comes off. Yes. I might have thought that it would come off more easily. Okay, this is going to be ridiculous. There's got to be an easier way to do this. This one's sitting on a shelf, becoming harder and harder to get off for the last century. Yeah, this is... Okay, but again, this is part of the value of doing this today. Try to head off things that you all will run into and have difficulty with. In just a second, I'm going to try using a heat gun for this. Okay, move these out of the way. There's one piece. Come on. Wouldn't that be funny if I made it worse, not better, by doing that? Okay, it is a little better. See how this side goes. Didn't get heated up quite as much. Alright, so that's definitely better. Still kind of tedious. Goodness gracious.